Hello and welcome to the second part of my Sakura tree tutorial series. This time we are going to focus exclusively on making the flower bunches to be scattered around the tree. So let's get started. In this case, like in many cases, I started from references, and those were the pictures that I took in botanical garden, and I decided to use those as base for my texture. So in Photoshop, I cut the backgrounds, and I used two of the flowers that I liked. And while the flower that I needed was the flower in the concept art was more pink, more bright than the original colors of the sakura trees that I had. So I did apply some color variations to the photographs, and I also added a leaf and a texture for this little leaf stems and flower bunches stems, and also a separate petal for the scattering purposes later, that we'll discuss later, like this little petals that are just laying around the ground. So I don't think that I did promise the tutorial for beginners, but I don't think that anything here needs to be really explained. So yeah, I have my albedo channel, I have my alpha, which is looks like this, and after I was done in Photoshop with cleaning and preparing, I got several textures, and I also applied blurred edges for proper masking. So in the end, I had my albedo, and I also had my alpha for the whole for the whole setup. After that, I took these two textures and I brought them to Substance Designer. Again, there are many ways to get normals, mainly for normals. There are many ways to get normals from photographs, and I think that everybody has their favorite one, but I'm usually using Substance Designer for that. So I plugged my bitmap into bitmap to material light node, and from here I extracted my base color, which again I didn't need, but just to have everything in one place. Then in here there are also settings for extracting relief, I mean normal maps. And here I have, so I did extract change settings for my liking, and I was just watching what's working, what's not. So in the end I had my normal map. Also I extracted roughness from here, but I didn't really like the original result that I got because it was too noisy, because of the photograph. So what I did, I blurred it. I made it more contrasty with levels, as you can see, and then I blended them together with max lighting mode. So from this initial result I got this, and that was my roughness. So let's continue. Then I used my alpha, and with the RGBA merge node, I combined alpha in red channel. That's the standard setup that I'm using, and I saw that Megascans and many other places, many other sources, tutorials do the same thing. So we pack alpha channel in red color, then we pack roughness into green, and a subsurface scattering into blue. For subsurface scattering I used roughness map, so I converted into, so by default, as far as I believe by default it's grayscale 16-bit, and I wanted 8-bit, so I plugged it just into blend as a foreground to convert it into L6. Then I applied levels to it, And well, I was orienting here on the leaf, and then I inverted my levels, invert grayscale node. This will make it a little bit better. I inverted them to have veins black, so veins will be less translucent and the other areas more translucent. Again, there are other ways to do that. It was the fastest because I usually have the setup ready to just different textures to plug and then just play with the settings. So in the end, I had my RGBA node. Actually, usually, I wonder why it's wrong here. Usually, you also need uniform color to plug into alpha. I don't know where I changed it, but so just a white color to plug into alpha. Yes, to have the proper result. And so then in the end you have ARS output texture, and it's C8, and I just saved my normals from here. Again, it has to be C8. If it's by default it's not C8, you might as well no, it is. So this is not necessary in this case. And then I had my C8 for ARS texture. We would not need this texture right until the moment when we get back into Unreal, so not today. So for today we only need albedo and alpha, but I still wanted to show the texture setup. So here are my textures. And another preparation step that I had to make is to prepare base flowers in 3ds Max. Again, this is kind of Houdini beginner tutorial, and I don't think that any of the viewers don't know how to do something as simple as this. You can still do it in Houdini. I just usually prefer to work with, in cases where I need to work with moving vertices, I still prefer to work in 3ds Max. It's just faster, it's just more convenient to me personally. You can use Blender or anything else. The only requirement at this point for flowers is that they need to be named. Like one of the meshes needs to be like flower A, the other one flower B. So we only need to give them different names to identify them later in Houdini. So what I did, I just put them at 0 coordinate, and you can see that the tip of the flower is at 0. And I saved them together as FBX. And the size of the flower is about, as you can see, the box is 5 centimeters by 5 centimeters by 1 centimeter. So it's roughly 5 centimeters in size. So it's about 2 inches. It's a little bit bigger than in nature, but that's what we have to do to save on polygons a little bit. So then I just selected both of them and I saved them as FBX file. And it was ready to be processed in Houdini. So let's jump right there. And here in Houdini, I brought in, so it's a file node. And so I just selected my file in here in geometry file. And you can see the original file. Then I always apply clean node because if you click with your mouse button on a node, you can see the description, the details of the node, or you can just over your cursor and press I. So it's the same menu, which just a little bit faster with the middle mouse button. Sorry. So as you can see, there are plenty of attributes that we don't need. That's why I use a clean node with the setting remove attributes, except this is how you make accept. So you do not delete UV and you do not delete name because we will need it. So you see that after cleaning, we only have few parameters to compare with this. And then important moment for anything that comes from 3ds Max, Blender, you need to scale anything. So use transform node to scale everything uniformly by 0.01. The reason is that Houdini works with meters. The 3ds Max, Unreal, pretty much everything else, except if you change settings. But I always have everything in centimeters because I work with Unreal Engine, which requires centimeters. So Houdini here needs to have settings changed. So we need to transform it So scale it down 100 times. So this is our initial flower, and you can see it's almost 5 meters. So these are meters. And then we transform it, and it becomes tiny, and now this is actual size of the flower, that 5 centimeters that we had before. So when you import in FBX in centimeters, you need always transform it. And then to make it just a little bit more convenient, I used Labs Quick Material node, and I plug it in. So I used PBR shader, and I plugged in my albedo and my opacity mask, just to make it more convenient, more pleasant for the eye, I guess, to see result as it is. And from here, while we have 2 flowers, and again, if you have more flowers, the process will be the same. We use split node, in which you can select, if you kept the name, if you made the name, then you can see your names here, and you select one of them, and it goes into A, and the second one goes into B. So here you can see that I have one of the flowers here, and another one is here. And then if you, for instance, have more than 2 flowers, so you select one of them in the first node and it goes away, and then the rest goes into the second node. And then you can use another split. For instance, you have B and C, and in this split you will select your flower B, and flower B will go into left pin, and then the rest will go into right pin. And so you can use as many splits if you need, as you want. Again, this is one of the many ways to split the polygons by name. So anyway, so however many flowers or whatever you have, this is the way to split them, one of the ways. Then I need, in my mesh, I need to separate this little bottom point. Again, there are plenty of ways. Let's see our points. There are plenty of ways to work with that, to do that. In this case, I decided to do sort by Y. So if you can see the numbers, after sort, the first point became 0. And after that, so we know that lowest point is always 0, and now we use group by range. We call the group cluster point, and we select group type points and start 1. So we selecting the very first point in the area. There will be another way, would be just group by a bounding box. So again, plenty of ways. So we attach the group cluster point to our lowest point in the flower, and after that we need to create an attribute from it. Not just group, but attribute. Like here you can see we only have point group, it's in green, cluster point 1. And with the group promote node, we create attribute from it. So group name cluster point, here you don't need to change anything. The main thing here is output as integer attribute. And now we should have it. So here you can see group cluster point, and here you can see cluster point attribute, and 1 is our lowest value. After that, I apply normals, soften normals to it, like this. And this is my just a empty null node to be able to just visualize what I have for the flower. And then it's easiest, I always do caps out in caps, so it will be just easier to find if I need to reference this flower somewhere. And after that, I create another attribute. I create a name attribute, and it's a primitive attribute, string. So let's see in our geometry spreadsheet, you can see that we have it. And how to do, so what we have here is, so this is the formula to pull the name of the previous node, the node that is coming into this node, pull the name as an attribute. So these little dots, those are not dots, these are little a sign that you have on tilde value. So it's next over tab button, next to 1, between tab and 1, this little yes, tilde, and then I don't know how it's called, like apostrophe, like reversed apostrophe. So when you create string, you need to do this. Yes, so that's how we create this name, because we want to have unique names on our polygons. Also, to make a little bit more variety, because I only had 2 flowers, I decided to do following thing. So this is my base flower, and I applied transform. So I made it a little bit thinner on X and Z axis, and I stretched it a little bit up in Y axis. So it's the same flower, just squished. And again, I applied normals, and I created attribute flower A2, and again the same value. And now you can see we have a second name. So we have one name, second name, and then I did exactly the same setup for my second flower. Absolutely the same, just because of the different name for the null node, we have 2 more different attributes for our flowers. And then we merge all of this together. You can see all 4 flowers are together now, and you can see all the name attributes right here. And after that, we need to process them a little bit. So my idea was to create clusters of flowers, like little bunches, like you can see here. There are bunches with different amount of flowers, like 3, 4, probably 7 flowers over here where my cursor is. So the idea was to create just random amount of flowers in each bunch and make it that way that flowers would not intersect with each other, so they would respect each other's boundaries. So to do that, first we need to find a radius of each of these flowers. So how do we do that? Well, for the first, we have 4 of them, and it's just easier to it was easier for me anyways to bring them into cycle for each loop. How do you do that? You do like this for each named primitive. So this is our cycle. We plug our flowers into here, and you can see that it has 4 entities, because we have 4 different names, and you can see that piece attribute is name. That's why we created names, one of the reasons. Anyways, and if you select single pass here, you can see all our flowers in each pass. So this is the beginning of the loop, of this loop. After that, we also need to, so after that, like in the beginning, don't pay attention to this node yet. What did I do? I decided to find a radius of every flower. So let's say we have a flower incoming. We need to find its dimensions, like maximum dimension on X and maximum dimension on Z. So we create attribute create node, and I called it max X. And so the node is max X, attribute is radius. Again, it's just name that I'm using. So name radius, nothing changing, so it's going to be point attribute. And let's look into it. So here's my point attribute radius. What does it do? It uses absolute value of position X of each point, and you can see that each point gets assigned its position X. So we use absolute, so it would not matter if it's which direction it's going. Px, that's strange. Oh, wait a second. Yes, so X, you can I'll make it a little bit wider. So you can see the px values with minuses or without minuses, and here in radius we have just size, because we don't need, obviously we don't need minus for the radius. So, and then I do exactly the same with pz value. So I'm looking for, again, just the same attribute, the same radius. So I create these 2 attributes, point attributes, then I merge them together, and now we have the whole bunch of values. So they're duplicating. And from here we add attribute promote, and we take our radius from point, original class point, and we create class detail. So this is our detail attribute. And what's convenient that we can promote not just all of them or average value out of them. In this case, we're interested in maximum, because what we want to find out is the biggest size, like the furthest this flower goes into any of this axis. And I do realize that it's not super accurate, but it's accurate enough for the purpose. So I'm promoting the maximum attribute, and you can see that the flower stretches out in one of the directions for this value. So we know that it doesn't go any further. So this is our final radius of this particular flower. So, and this is detail attribute, and now we need to promote it back to the point. And now if you look back to the point here, you'll see that now all the points have the same radius. And don't pay attention that they're duplicating. It doesn't matter, because what we do now we get back to our original value. We create node attribute copy, and we plug our original flower into A. So geometry to copy attributes 2, and we copy attributes from this geometry. So now we have our flower back, just original version. And all this setup was serving just one purpose, to find the radius. So now we have it. Now our flower has assigned attribute. Also, what we need is to assign flower type, pretty much the same as similar to what we have here for the name. And maybe this setup could be actually changed, so we would not need to do it again. But it's always like afterthought. So here what I did is I created a new attribute named flower type. It's integer attribute, point integer attribute. What we plug in here, we need to, so while we have cycle of 4 flowers, we want to assign a number according to the cycle number. So if you have 4 cycles, and this is cycle number 1, we want this flower type to be number 1. So how to do that? If you click in here, you'll see that there is a button, create meta import node, and we didn't create it here yet. So here you do this, and you receive this meta node on the side. So this was demonstration, I'm deleting it. So this is how I got this node. I always name my nodes in something that would make sense. So flowers amount, 4 flowers amount, let's say incoming flowers amount. So this is it. So when you go to flower type, you go into value, and you type in, so we're referring to our node flower amount. This is the syntaxes that you need to use. So detail, so we're referring to detail attribute from where? From the node flower amount. Which exactly attribute? Iteration, because when you create this attribute and you go into details, you can see that there is num iteration attribute. There are 4 iterations, and there is iteration. We are on the first iteration, and Houdini starts everything from 0. So first iteration in Houdini is 0. The last one will be 3. So what we want to do, we still want to refer to this iteration, which is 0, and then it's a first one. Well, right now it's the only one, but in some cases you need more than. So if it's only one, it's 0. It's always 0. So we're referring to the node, the attribute, the first value of this attribute, first dimension, let's put it this way, and we add 1 in the end. So 0 becomes 1, 1 becomes 2, and so we will have our attribute from 1 to 4. And you can see here, if we click in here, you see that flower type is 1. And we also want to do is to promote this flower type attribute from point to primitive, and we do first match, because, well, that's what it is. Like pretty much anything would work here, because we only have 1 of them. And also pay attention, we do not delete original. So at this point we want flower type to be point attribute and primitive attribute as well. And this will be the end of initial processing of the flowers. And if we see, so okay, on the first iteration we have flower type 1, on the second iteration we have flower type 2, and so on. So the result here is, again, our flowers processed with radius of each one of them, and with flower type assigned 2 points and 2 primitives. Let's move on further. Here we delete the name attribute as far as I remember. Yes, we delete the name attribute, and now our situation is a little bit cleaner. Okay, so now let's get to the a little bit more, I guess, complex part, but and maybe of course it could be done some other way. Probably the best idea would be to assign to create bunches of flowers manually, maybe. But I made it set up to work with roses, and I wanted to do, and I actually did HDA to work directly in Unreal, and I wanted to be able to select how many roses I want in each batch, so I could have bushes of roses with just like tea roses, one flower on stem, or with bunches of roses, like English roses. That's why the complexity. But as to me, it pays off, and it's not that difficult to create. So let's get to it. So what do we do here? First, we create a sphere. So let's get to the beginning. We create a sphere on which we will scatter our flowers. And if you look into like how flowers are kind of working in real life, they kind of they go like they look like if they build around a small sphere. Again, we will not be able to do exactly this, but it will be similar enough, at least to my liking. So first I create just a sphere, random sphere with just basic parameters, polygon mesh. Then I transform it. I just make it smaller. I just make it like really small. And I create a spawn region group. Again, one of the ways to make groups. So what I do here is I name the group, I name the primitives spawn region. Let's turn on wireframe. Wireframe is Shift W, by the way. So here we select primitives, we uncheck base group, and we just make us like a tiny, as you can see, tiny little box that will encompass what we need, and we do include partially contained entities. And here I'm using the center of this box would not be 0, because I mean X and Z would be at 0 because the sphere is in the middle of coordinate at 0 coordinates. But here I use this formula bbox 0d max y max, showing that the center of this little box, selection box, would be a highest point of my incoming 0, so their incoming geometry. So that's how it made. And include partially contained. Now I have all of them selected, and I attach. There are normals. Normally normals are attached to vertices, but I wanted to attach normals to points. And so here, if you can see, so here we only have, if we turn on normals over here, we can only see vertex normals, which is standard way. But with this little command, attribute wrangle, so just start typing wrangle. So it's like simplest code setup. So with attribute wrangle, I assign to my points, because I'm running over points, I assign the normal value of vertices, which these points attached to. That's why you can see here, we have normals attached to the points. That's going to be important later. And here I was experimenting with different ways to scatter points, and both of setups can work, but I came to conclusion that scatter and align setup works a little bit better. So what I did here, so my goal here is to scatter a few points, the amount of points that I would want to have in my cluster, on top of this sphere. So you can see our sphere, and so when we do scatter and align a node, or scatter node for that matter, we use group as spawn region, so the one that we only selected here, so only the top part of the sphere, and we scatter some number of points. So we select the method is number of points, and let's say 6. Right now, global seed is I just looked into the one that I liked at this in this case. So number of points set up, coverage is 1, so like to cover the whole area. What is good about scatter and align node is that you can actually rotate every instance that you would. So here are the points where we'll scatter our flowers, and you don't want all the flowers pointing in the same direction. Let's see how. I'll just plug it in the end. You'll see the end result, and I'll show you what I mean. So you can see the flowers look kind of have random rotation here, but if I do this, they will be all rotated their original way, so all rotated in the same direction. And just making a max angle different allows me to rotate them randomly. And it's kind of noticeable if they are rotated in the same direction. So we're rotating flowers around normal. You could see the normals pointing out of each point. So that's why, and the whole setup is a little bit more compact if you use scatter and align. So let's get it back here. So first we have our 6 points. And again, we'll get back to the randomization later. So 6 points, max angle, min angle. You can also do in point generation. I use normally here you have 10 relax iterations. I always make it 100, so the points would be scattered more uniformly. In this case, it's important. And also with attributes tab, I uncheck. So by default, radius attribute is on. I unchecked it because later I will set up p-scale attribute myself. And also the default attribute value here is just orient. And I needed to get rid of it because this orient would screw our copy to point later. So what I did, I rearranged, I renamed, as you can see here, original attribute into orient base, because here you can see orient base is 4, so it's 4 vector. Let's see what it is. 4 floats, so it's vector 4, and we need quaternion. So we will deal with this later. But right now, because our attribute here is a little bit not what we want, we need to just rename it from orient into something else, whatever else. I just renamed it into orient base because we will need it. We will need to convert it later. If you do scatter though, it's a very similar result, but you do not have orientation at all. And then that's why it's a little bit more clunky, because then you will need to create the whole setup to assign orientation to it, to assign this random rotation around normal of each point. So scatter and align is better from this perspective. So let's say we're using scatter and align. I'll show how to use scatter as well later. So this is the end of the setup for now. So we have our points. We can make 10 points, whatever. So right now just let's stick with 6 because it doesn't matter at this moment. So also what we need now, we need to, like, while we have our 4 flowers, each one has its own flower type attribute attached to it. Now we need to say, okay, we have 6 points and we want random flowers to be scattered on these points. So we need to assign to each point a flower type attribute, starting from 1 and to however many flowers we have. So let's just get to it. So we have our attribute create. It's named again flower type, its point attribute, and its type integer. And by default, we create value 1. Now we need to, so in here you can see we have just 1, but we want to randomize it. So we use attribute randomize node. We use our attribute name flower type. Let's step into it, and you can see already that we have random flowers, random types. Again, it's right now you don't even see 4. It's just because it's random seed. So it just didn't happen in this case. Okay, let's just take another seed, and then later we can randomize random seed as well. So what we do here, we again use the flower type attribute. We do distribution uniform discrete, and our mean value is 1. That's right. Our max value has to be a number amount of iterations in here. So we know that we have 4 flowers, so we have 4 iterations, and we can reference this node again to actually create the maximum random number in this node. So that's how we do it. So we referring to this detail attribute, flower amount. Oh, amount of the flowers. That's weird. Hold on. Okay, it's here. I'm sorry. We could reference it too, but and that's what I would do now. But I guess when you work in, sometimes it just doesn't work like this. So yeah, the same point. We could reference this node, but I created a special node attribute from. So I promoted flower type from, and I made it detail. So in here you can see we had flower type from 1 to 4, so we know that 4 is the maximum. That's why in here I use flower type, create detail out of it, and I use maximum. So here you can see that we have detail flower type. But again, it would be actually like we could get rid of this node and use just this node, because here we have num iterations attribute, which shows us exactly the same amount of flowers that we have. So this is actually a good example of showing how everything in Houdini can be done in so many different ways. So anyways, here I'm referring to this attribute, amount of flower types. The name of attribute is flower type, and the number reference number is 0. I might as well do refer to here flowers amount, num iterations 0. So again, whatever you like. Both of them would work. And so at this point, each of our 6 points has assigned random flower type attribute. And what we need to do is to use another attribute copy node, and we need to assign. So now we have our 6 points, and now we need to use the radius from our flowers. We need to assign to each of the points. And we also need to make sure that our big flowers will, so the flowers would not be mixed. So now we know we have flower type here and flower type here, so like in common and the other one. So in attribute copy, we check match by attribute, and we use attribute to match flower type. So if we have 4 here, then we check what we have here, and we only use like radius. If flower type is 1, then the radius would be this. If flower type is 2, then the radius will be this. And so we assign to each of our points, we assign a radius attribute according to their flower type. I hope it's not too complicated. It sounds complicated, I understand, but still. So now we have all 6 points with flower type assigned and with radius assigned. So you can see flower type in here and radius is in here. What I also wanted to do, I wanted to use a little bit more variation. And so I decided to not allow each flower to be just its original scale. I wanted them to be, some of them to be a little bit bigger, some of them to be a little bit smaller. So from here, I created another attribute, p-scale. So p-scale is basically a scale of our flower. Of anything, and so 1 is a default scale, so it's exactly the same as what's in common. So we create this attribute, it's point attribute, and we create a value 1 by default. And now I want to randomize it a little bit, so I create again attribute randomize node. The name we're going to work with is attribute p-scale. Again, distribution is uniform discrete, dimension only 1. So, and then our mean value, so I want flowers to be a little bit smaller, so like 80% of their size. So from 80% to 100%, so a little bit smaller to the default value. And step size would be 0.05. So it can be, let's see here. So here we have all the p-scale are 1. So all the flowers of their original size. Here we already have, each one is assigned a different p-scale. And the step is this. So now we have 0.9, 0.95, 0.8, 1, 0.95. Again, randomly. And so from here we have our from here we have our radius, and here we have our scale. So now, like if you think about it, if the flower becomes a little bit smaller, the radius of the flower becomes a little bit smaller too. So now we need to account for that. So how do we do that? We use attribute expression node. In here we create two expressions. Let's see how it looks by default. Attribute expression. So this is how it looks by default, with nothing coming in. And we plug our node, and you can see there are several pins and we can use them. So we plug our original points only with radius, and we plug our p scale into the second node. And now we need to write some expression, like what we want to achieve, which math we want to create here. So let's see. So we need to have two expressions. So first we're going to work with our radius. So you can see here we already have the first attribute we want to work with. And you can see that there are several attributes available for working. And while radius is not a usual attribute, I had to select custom, and I select radius, and it's float as it is. And what we need to do, so we have incoming radius from our flower over here, the one that we found out in this first loop. So we have an incoming radius, and we need to scale it according to p scale. So if this original radius is 1, equal to p scale 1, then if we have p scale 0.8, our original radius has to be multiplied by 0.8 as well. So what we do here to find a new radius, so we kind of rewrite our original radius. Like you can see here, we have radius, let's look at the first one. This is what we have for the first one. Here, it's a little bit smaller. So our p scale is 0.9, and that's what we do. Self means whatever is coming in. So if we're working with radius, we take original radius, so self, and we multiply it by this, how to say, a formula. OP input 1 means the node that comes into here, the node that comes into the second pin, because again, first pin is 0, second is 1, 2, and 3, because everything starts with 0. So we're interested in the pin number 2, in value that comes from pin number 2. And our pin number 2, I mean, the second pin is number 1. So this is our so what we're saying here is, let's take whatever comes into the second pin named p scale. So we multiply our incoming radius by our p scale coming into the second node. And that's it. And that's why we have big radius here and small radius here, except for 1, because here radius didn't change. And then when we're done with the first line, we can create another attribute vex expression, and we need to work with our scale. So now we need to assign to our original flowers, we need to assign p scale that we created over here, and we just created. So our attribute, we work with scale, and it's a standard attribute, so you can find it here, and that's what we do. Like we assign attribute p scale this value. It's the same as here. So we assign whatever comes into the second node, the second pin. And so here we have our radius and our p scale, and it's all pretty much done. And now what we need to do is like, okay, so these points are very close to each other, and now we need to spread them around along our original sphere, I mean our original transformed sphere, kind of spread them around along to be able to fit the flowers, because now we know the radius of the flowers. And after scaling, we now have like final radius of each flower, and so now we need to spread these points to feed the flowers, and that's what we use the relax node for. So you can see here our points are pretty close together, and if we do relax, they spreading apart. And in here we do like a lot of iterations, so to make the process more accurate, and we use point radius attribute radius that we created. And again, for some reason, so let's see for better visualization. Let's do this. I created a sphere for test. So I created a sphere in which I plugged largest flower radius over here. So as you can see here in details, I have radius, so I have this value. I was like, okay, so this is my value for each of the flowers. So in loop, this is the radius of maximum radius of each flower. So I created this sphere referring to it with size. Again, you already know how to work with details. So again, details, the largest flower radius 0. So this is my value. I use it for widths, for lengths, widths, and I divide it by 2 in height. So now I have this. This is like my biggest flower. So I divided it by 2 in y. That's why it's squished. And also to make it not in the middle of the so to make it center position, not in a 0, to lift it up. What I did here, I just selected this node, right click, copy parameter, and then I did paste relative reference, and that's what I got here. That's how I got my radius y here, and that's why it's at 0. So let's say instead of the flower, I have my sphere, and let's plug it into here instead of our flower. So now each time all this beauty on each loop, all this math will be assigned to this sphere. So you can see in the end we'll have several spheres representing our flowers with their sizes. This is just for demonstration purpose. Let's see how it works. So if we go to the end of our setup, this is what it's going to look like because of the relaxation. So technically, you're kind of supposed to have one here to make them completely separate from each other. But you can see for some reason, I don't know why, for some reason it looks like it's a little bit like too big. So I found out that 0.8 value is kind of perfect. And what's good about it, what's nice about it, is that if we change the amount of flowers, they kind of fit in nicely together. Again, sometimes there are errors, but I deemed it good enough. By the way, to be able to do this, you need to put your cursor in the middle in a cell, press middle mouse button, and then drag. And you can drag in tens, or you can drag in different amount of points, of numbers. You can move it at once. So okay, let's say 8. Let's say, I don't know, 5. No, wait, let's do 7. Oops, 7. Okay, so this is what this relax node is for. As you can see, if we skip it, everything is squished together. And also in relax node, sometimes it might be valuable. You have this relax in 3D space. So if you choose it, it tries to separate them. And actually, in case of roses, it looked pretty good in some cases. So sometimes you might want to actually relax them in a 3D space. And maybe in this case, you will have to have a little bit less scale of the radius. So we don't need 3D right now. So let's do this. And again, if I plug in flowers instead of the spheres, we'll have this. And with flowers, you can actually make a radius even smaller. So yeah, let's say 0.5. I don't like that all the flowers somehow we have a lot of the same type of flower. A random is not very random nowadays. Okay, let's call this one good. So let's get back to our things. So we have relax. This is I showed you why relax is important. So now we have our point relaxed, and now we need to sort them. And what we need to find is the tallest one, the tallest point. So we have the numbers. So now we want to find the main one, like the central. Let's call it a central point. That's why we sorted by y, and then we do reverse point sort. So now the highest point will be 0. And now we transform them. Now we put them, we want to move them down. So all the flowers will start at the beginning of coordinates. And how we do that? So what we want to do is to make sure that the lowest point is on the 0 vertically. So like the lowest point is laying flat on the ground. So that's the formula to do that. So we use y minimal, so minimal of the in the y-axis, and we find our minimal and we move the whole thing down on this value. And so that's how we bring them to 0. Also, I was accounting for the case where we have just one flower in bunch, because again, as I said, I was working with roses initially. And so if we only have one point, let's say 1. If we have 1 point, we don't want it to be somewhere. We want it to bring it to the center of coordinates. So we want to do this. We want to put it right into the center. That's why there is a attribute wrangle where we just assign to point position, we assign 0, 0, 0, and we bring it down here. And in switch, well, that's what actually needs to be changed here, because I changed it from scatter to scatter and align. So in this switch, we need to be able to tell how many points are created, and if it's equal 1, if it's only 1 point, then we use the second root. If it's more than 1 point, we will use the other. I mean, if it's any other value, not 1. So here I'm using the old scatter that I had, and what we need to do is we need to go to our scatter and align into total points box, copy it, or just right click, copy parameter, go back here, and in channel, instead of channel, we do like select the value of the channel and right click, paste relative reference. Oh, hold on, no, actually the whole channel is our, the whole channel is our reference. Paste relative not including if, of course, because this is hyphens, brackets is from if node. So paste relative reference. Okay, finally. So that's what we do. If this equals 1, we use the second node. So this is our, and what doesn't work, unable to, bracing error. Okay, what's the error? Yes, this one is extra. So if this equal 1, we do 1. Otherwise, we do 0. So 1 is the second node, 0 is the first one. So you can see it worked. And if we here we put more than 1, like if we put back to 7, it switches to the first node. So it's just, again, a quality of life change. And it shows you that now it uses 0. So first incoming value. The first incoming operator. And also, so now we got it on the floor, so now we have it at the beginning of the coordinates. We can also choose the lengths, create the lengths, set up for ourselves, and actually it can be green, because we would know that there is something that we input here. We need to make the lengths, select the lengths of these little stems, these ones, that go from every from every flower. How to explain this? Because then we'll be working with this later. Well, yeah, kind of how far the flowers would be from their stem. And so yeah, here is just 2 centimeters, just a value that I found looking good. And here we need this a little bit of magic that we unfortunately have to do to fix orient here, as I pointed before. So here we have our orient base. As I said, it's not quaternion. We want quaternion, and it's float 4 vector. And so we go into here. So we create attribute VOP. It's right click, VOP, attribute VOP. you plug it in, and you go inside, and in this case we can delete all of this. So it's super simple. So we delete everything, and we bind our orient base attribute. So you select bind, and this is what it is. Here you type your orient base. Oh, hold on. First we need to first you need to select in type. So we need to select type, which is for floats vector 4, and it's named orient base. Okay, so now it's bind. So we taking it in, and we outputting it into orient, proper orient attribute. As you can see the settings, and we just do this. It looks really ridiculous, but for somehow, so it's the same, but somehow this operation changes it into quaternion. And you can see that here, if I click middle mouse on this node, you can see that orient base is for float, the type of attribute. And if we click here, you'll see that we have orient, which is for float quaternion. And this makes it huge difference. And you can see here we already have all this orientation value. So we have our up vector, our normal vector, and our the third one. Actually, I don't even know how it's usually named, like X vector. And again, how you can show or hide these vectors by doing this over the node I, and you can press just with mouse on your orient. So this is how to show or hide the attribute. And you can see here that if we come back to our scatter and align, and we make orientation 0, so see all the flowers will be oriented the same way. And with this, we just make them oriented randomly. So this is like the best, because this is the cleanest way, as to me at least, to make them spin around the up, in this case up vector. Usually it's called around normals, but it's not normal, because normal is blue. I mean normal, point normal. So we're spinning our flowers around point normal, and that's what we do. So after this, we can use this is again just for demonstration. We can use copy to points node. You can see copy to points. We bring our flowers into geometry to copy, and then we bring our converted orient into points to copy, and our piece attribute is flower type. And as you can see here, we have our flowers spread around, nicely like wrapping around. So yeah, and they are all rotated randomly around their axis. On the other hand, you can achieve very similar results with just scatter node instead of scatter and align. Let's see what this does. The problem with scatter node is that we do not have this node does orientation for us. Scatter node doesn't, so we need to deal with orientation ourselves. And for that we have like a big setup. Again, another attribute VOP, and it's really huge with many parameters. I'm not going to even get into explaining this, because I can show you, I can recommend the video explaining in great details how it's like a big lecture, how it's done, because I'm not capable of creating this myself. So this is the video where I learned this technique. So it's a two series, 2 parts tutorials, each one of them, as you can see, like 2 hours long. And here he explains in many details everything about these quaternions and about rotation matrices. And to me, it's kind of a little bit too much. I mean, I can follow a tutorial and make it work, but the math is the math is complicated. I mean, again, he explained it so nicely that I understood everything, but then I forgot everything just as fast. So anyways, I recommend this video. It's really, really good to understand these things and then just work with them even if you forgot what is all this for. So yes, a little bit more clunky setup to achieve pretty much the same result as we achieved with scatter and align, and this little fix to turn everything, to turn matrix into quaternion. So let's get back to our scatter and align node, and here, as you can see, this one works too, but it's but instead of, we can use a very short one. And this is nothing. This was my experimentations when I was trying to make it work. So, okay, we are done. Let's say we're done with a bunch of flowers. Now we need to create these little stems that will connect them together. And maybe actually we can do a little bit less in relax attribute. We can do a little bit in relax node, a little bit smaller radius too. Again, this is like a question of you know, sometimes if there is a little clipping occurred, maybe it's not a huge deal. Depends on your taste. So let's get back to creation of little stems that will connect each flower together. Okay, so we started with line. Super simple. A little line, 6 centimeters long, 4 points, nothing to it. And here we use group by range. We name it attachment point. So this is the point where our bunch of flowers will be attached to the branch later. So this is our initial point for the cluster. We call it attachment point, type group points, start. So we select in first point and invert range. So like this is the way to create many points in a row. Again, you can use just group. You can just, knowing that it's point number 0, you can just select it by, you know, by its, but knowing that it's 0, you can just select it. But I usually prefer to do as procedural approach as possible, because what if for some reason it will be, you know, reversed. So I always trying to make it, again, if it will be reversed, it will not be first point, it will be last one. But anyways, I usually trying to not to rely on like point number, because what if I'll have 15 points like this, then on the next one it will not be 0, it will be something else. So like I'm looking for the first point. By the way, if you have several, you can use connectivity, and if you do this, then if you have several lines, you will select the first point of each one of them. Okay, now we need to select the last one, because this is will be our cluster point where all our flowers, flower bunch will be attached. Okay, so we select our points. Now it's time to transform, and I just like rotate it a little bit, as you can see in x-axis, just to give it a little tilt, so it will not be, you know, straight like a stick. And now I bend it a little bit too. Actually, I don't even bend it here, but again, you can do that. I put this node because you know, sometimes it's needed, sometimes not. In this case, it's not really needed. And also, I am using point jitter to make it a little bit like to vary its shape. And I group, so I'm jittering everything except attachment point group. So you can see, so our first point will remain intact. So exclamation mark and then attachment point, and this is our scale. And yes, and I do not jitter it in z axis. Actually, I don't even know why. And then I smooth it just the same, except attachment point. So attachment point needs to be at 0. So I smooth it. Now it's kind of jittery, but not as bad. And connectivity node allows me to create attribute branch, which we will need later. So it just creates this first attribute, and it's 0 because everything starts with 0, and it's integer type. Then we have our expression, and here again, this is the case where you can do things multiple ways. In this case, for some reason, I decided to make branch with the value, so whatever comes in, self plus value, and value is 1. So instead of 0, we receive 1. Okay, so now we need to, so we have our tiny little branch, and now we want to attach our flowers from here to make them be attached to that point, like be aligned with this point. So what we do here, so this is our line, this is our little stem. We use the node orient along curve, and if I turn on normals, you can see that without it we don't have normals, and orient along curve does our, let's see what we have here. We have our up too. So you can see that this is the node that creates normal vector in y-axis, up vector in y-axis, and normal vector as a tangent. So you can see them here. And I know that in my case I will need to do this to so it's additional rotation tab, and I do apply pitch 90 degrees. So because I will show you what will happen if we don't do this. So that's the only difference, the only thing that I'm changing in this node. And now I'm blasting everything except for this, our cluster point, the last point, cluster point. And we needed to do this first because we needed to have the whole curve. So Houdini, this node, would know how our curve flows. So we need, like, you know, several edges to find out the direction of the edges. Because if you blast from the beginning, if we only end up with one point first, now the Houdini would not even know, like, okay, this point is how it's related to other point. That's why we need to do it first, and then we remove everything except delete not select everything except cluster point. And now we need to copy our cluster into here, and we use copy to points node. And now it looks too difficult. So our target point is cluster point, and again here we can really delete it because it's the only point remaining. But still, you know, for the beauty, because what if we would not, you know, blast it? If we would not blast it, then it will be still the same because we grouping it here. Okay, let's turn off our quaternion so we would be able to see our points. So okay, so now you see that we had our 1 point, and as you remember, our flowers were just a little bit over the 0 point, and now we copy them onto here. And if I reference this, you can see that we have our little branch, and our flowers are copied to points exactly the way they need to be relative to this branch. And if we, for instance, if we make this branch, I don't know, longer, it will follow. Or if we bend it, it will follow too, which is extremely convenient in some cases. So now we, because of this orientation along the curve, now we have this all working like independent. And let me show you what it will be if we do not apply pitch change. So now it will be attached sideways. That's it, because of the difference. Because our flowers, it's just more logical to me, easier to understand. I orient them in up, so they face up, but in Houdini default facing side is z axis. That's why it's, if you want to use up, then you need to apply this little additional rotation. So this is our flowers ready pretty much to be attached. Let's see what we do also here. So now we need to run through the flowers, through each of these points. And again, this is kind of not needed in this case, but it was needed with roses. And by the way, at some point I will get to making a tutorial about roses setup. There it will be needed, because then we'll have like totally unique flowers all over the bush. Here you can skip this step, but I'll show it because, you know, it's already here. So we have our 7 points already placed where they belong, and we go through each one of them. So by pieces of points, merge each. So it's the same standard loop that as I showed before. we create each flower, we create meta import node, name it each flower. So what we do here, so our incoming, let's say first point, you can see its attributes. So flower type 1, and all the other things that we created, and they were created for us. And now I want to create attribute, flower attribute, that we didn't have before. And what I want, as you can see, I want it to be, well, first, so let's say, again, it's not really needed in this case, but it may be needed in other cases. Let's say you have a bush with several clusters, and you want each cluster be unique. So, and now in each cluster you have flowers, and each flower, let's say you want to be unique. And so now you have like a system of coordinates. You have first, you need to specify the cluster, and then you need to specify a flower in the cluster. And that's what I'm doing here, which is not necessary, but bear with me. Not necessary here, but yeah. So I'm creating a string attribute named flower, and the string that I'm creating, as you can see here, it's like 1_7. The string that I'm creating, I'm taking detail attribute from meta clusters, which are somewhere in the future. Meta stems, or maybe it's not even meta stems, meta flowers, not even in this, huh? Oh God. Well, I guess it's not. Yeah, it's not even in this setup. I'll still explain. At least I'll explain how to make a string node from integer. So I take, in this case it's 0. That's why it will be 1. So it's 0 because there is nothing here. Because there is no meta clusters node. At least I cannot find it. So I take the iteration and add 1 to get the first iteration. But if we did have this, and in future I will show later how we can use it to create like really unique setup. So the first iteration is 0, and we add 1 to have 1. So this is how we get 1. And again, we use this little tilde button sign in the beginning and the end. So we transforming our integer from here, we transform it into string, and then we just put in underscore, and then each flower is our current node, current meta node from here, and we use a detail from it iteration as we did before. So each flower plus 1. So if this flower is the first flower, then we'll have, let's say, yes. So this is the first 7. Single pass. So let's take the first flower. So the first flower would receive attribute 1_1, because again we use iteration number plus 1. So the first iteration, which is 0 iteration, so it means it will be 1. So our first flower is 1, 1. If we scroll through the other flowers, they will all receive a 1_ and then number. So now we have, this will allow us to have, let's undo this, single pass. So now we have each of our flowers has its own unique string attribute. And in here, we also create attribute about amount of flowers in cluster. Again, it's integer, the name, and for the value we use iteration plus. This is actually the same as in here. So pretty much this one is not even needed in this setup. So flower in number of the flower in cluster. So each of the flowers has its own number, starting from the 0 iteration to the 6 iteration. So this kind of just extra in this particular case. So okay, now we have our cluster, and we assigned attribute to it. And now we can go and actually copy flower to each one of those attributes. And remember that we had flower type here, and so we take our flowers from the beginning, our bunch of flowers, and we use these points to copy flowers to points. and we use flower type as a piece attribute, and now all of them are copied into place. So by the end of this, in the end of this operation, we have our little stem. Let's see it. So you can see our little stem and our flowers oriented along the stem, and we can, again, with bending and other things, we can play with this. So now it's truly procedural. And the last thing that we need to do, last thing for today, is we need to actually connect each flower to this stem. And so let's dive into this. So how do we do that? Let's imagine that so each flower has this little point that we assigned in the very beginning. And so we need to attach, first we need to create a little line that will go in perpendicular, perpendicular like a flower. If you imagine flower as a flat plane, so we need to make this little line perpendicular to this plane. And then we need to attach all them together. So let's do just that. So first we create a little line. And as you can see here, a line starts from 0, but it goes into direction -1. So because we need to attach it to the flower, and the flower is like this. So if this is 0 point, the beginning of the flower, then we need to put the line not up, but we need to kind of go into opposite direction. So, okay, so this is our line. We make it flower stem lengths. Okay, this is finally, I remember why I did this transform. So, no, this transform, flower stem length. So here we put this value, and in here only, it comes back like have some meaning. So if we change this, not here, sorry. If we change this, our line becomes longer. And that's why I love procedural stuff. So how we do this, we go in here, right click, copy parameter, go in here, and when it was empty, paste relative reference. And we make it super simple, just 2 points, so not even bending, for saving, resources saving, polygon saving sake. So okay, we create our line looking down, then we sort our points. Let's see the numbers, and we're reversing our points. So we'll have 0 will be the point which will be attached to the stem. Then we reverse our vertices. Vertices that, I mean, that you cannot really see them, but so you can see here we have 1 to 0 because our line is inverted, and we need to kind of flip it. So it will, from the perspective of the Houdini, it will start from here. So first we reverse the sort, and now we reverse the line itself. So it was starting from here, going down. Now it starts from here, from 0, and it goes up, but it still ends up in here. Again, there are plenty of ways to do it other way. It's just, to me, it's just simplest. So now we have our flowers, and we need to copy this line into each of these points, each of the points where our flowers are attached. So remember, before we attach flowers, first we had points where the flowers were attached. And now we use the same setup to attach our line. And now you can see this. So if we look into our flowers, you can see that these little lines are going exactly perpendicular to the flower plane. So we did this, and our target point is cluster point. Cluster point in here, in our little let's turn off up vector. So cluster point is the last point of our stem. Okay, so we created our lines, and now we need to create an attribute which is called flower stems. And I'm not even sure really why I created that. So let's see. It was a while ago. So I can see it's integer attribute called flower stems, and its value is 1. We can see it here. Let's see where it takes us. Then we promote our attribute flower. Attribute flower is this is this nice and big unique string attribute. So we attach to each stem, we attach this attribute flower. So it goes into primitive. We do not delete original. So now we have each line has its flower attribute. And we also attach flower in cluster. So we using these two attributes that we created, we using them into attaching them, transferring them into these lines. Okay, and now we delete what? If the flower stems 0. I think that this is for the case when we have just one flower. I'm not sure. Let's see, because it's been a while when I created this, but there was some reasoning behind it. And flower stem is what? No, flower stem is still 1. Well, I guess we might as well ignore this delete. I'm sorry for that. Let's get back to something. Let's get to 8. Let's get to 6 for easier visualization. So yeah, I'm not sure what I was doing here. Okay. Well, let's get going. Wait a second, primitives. Well, okay. So what do we have here? So let's get back to our stem, original stem, and we need to separate it for the future reference. So we add it into group branches. Just super simple group node, name branches, primitive, and just enable. And so the whole one primitive that we have here will go into this group. And now we merge our big branch that we just named, add to the group branches, and our small branches. So now we have this. Let's turn off point numbers. So now we have this. We have our original stem and our small stems. And now we need to connect them together. Procedurally, of course. And we promote an attribute branch from point to primitive. So now we have, so here we had it only attribute branch. Hold on. So it was just group, branch point. So okay, so there was attribute branch which was point. We turn it into primitive over here because here we didn't have this. Now we have attribute branch as primitive, and we do not delete original. And now what we need to do, so now we have a bunch of stems, and we need to connect each one of them, a bunch of smaller stems. We need to connect each one of them to the big stem beautifully. And of course, while we have more than one, we need to make another for loop. Actually, with even it's kind of complicated, but okay, let's get going. So what we do here? First, we reset. Okay, reset. It was cached value from who knows which time. So this is what's incoming. First, we need to separate our big branch from small branches. And that's how we do it here. So we use split and we use group branches. That's why we grouped it in here to separate it from smaller ones. So we separate branches, and from here we have already two paths. So we select AND node. So this is the point where everything will be connected. So it's called AND. It's a point. Just one from the end, as you can see. and invert it. So this is our group, and now we need to promote our point to the edge. So that's what we do. We do group promote auto, which is we only have end group about points. So we promote an end to end edge, and we promote to edges. You can see, and keep original group. We check keep original group. So now we have the whole top part selected. On the other hand, let's get back into our second line of things. On the other hand, we have our stems, and remember that we over here in the very beginning, not in the very beginning, but over here, after we relaxed our flowers, we sorted them. So the top flower would become, and I was pointing at this, so the top flower will become the main one. So we made it 0. So it's a first point, and so when we copied these little stems onto these points, it became, like if you look into primitives numbers, the primitive that was attached to the 0 point became 0. So this is how we make sure that our highest flower will be the first to be dealt with. So it's like it's the middle, it's the highest, so it's going to be our main stem. And we know that it's going to be 0 because of this sort here. So in here we have all of our stems, and we know that primitive number 0 is our main one, and we need to select it. So how we do that? Again, group by range, but in this case group type is primitives. We name the group main flower stem, and it's a first stem, and again invert, because otherwise it would be selected. It will be not selected. So invert range, and this is it. And now we're splitting it. So we call it main flower stem, and we put in split node, and we split by this group name. So on the left, so when we select this node, we see what goes into the left. So on the left, in the first output, we have our main stem. On the right, I plugged null just to see. On the right, we have all the rest of them. So let's first follow the main one. So main one goes first. We promote main flower stem group. So initially, this is the primitive group. We want points to know that the points belonging to the same group. So that's why we promote main flower stem 2 points. So initially we had it group main flower stem over here. You can see it over here. And now we don't have group anymore because we deleted. We didn't keep original group, but now we have it in points. Where is it? Okay, group main flower stem. So both points now belong to this group. And we also need to find the first point out of 2. And again, we call it we call it end, just like here. This is on purpose. So we call it end. It's the first point, invert range. Like we did this several times, you already know by now. So, and now we merge our main stem with our small main stem. We merge them together, and you can see the results. So they're not aligned, but we still need to connect them. So what we do now we have our end from here and end from here, and after merge we fuse them, and we fuse them with the fuse node by group end. So only nodes from end group, only points from end group are getting connected. And again, the distance snap distance can be larger because we only need to connect 2 points, fuse 2 points. So here it can be really whatever, reasonable. And our position, usually it's average value, so it will be somewhere in the middle. But we want a small stem to actually be extended and get to the bigger stem. And while the biggest stem has a smaller point number, because from here they're all attached, as you can see, they're all assigned. So this one has point numbers 0, 1, 2, 3, and then this gets the next point number, so it will be 4. So the main stem would always have least point number. That's what we use here when we make the small stem to go and be attached to the big stem. So that's our result from here. And then we sort it again, so all the vertices will be in a correct order. It doesn't look like it's necessary, but sometimes it is necessary. And plus, oh yeah, so anyways, we sort them. You can see the result. Now we select both ends, and we call them ends, points from both sides, both ends. And we only needed to make them not being affected by smooth by the next operation. So we have our smooth here. We want to make it more, we want to make it nicer. So we smooth everything except ends. And we polypath it. As you can see here, we have still two primitives. Even though we welded points, we still have two primitives. And polypath just creates one primitive out of it. Okay, and from here, what we do now? Now we need to attach all the rest of the small points to this to this setup. So we dissolve everything except end edge. So end edge, we created it over here, and we still have this group because it's edge group. It's still intact. So we did here. We dissolve everything but it. It's only changed the position a little bit because of the smoothing. So, but it's still the same. So we dissolve everything else, and we scatter on it points with a scatter node. How many points? As many as we have remaining little stems. So let's see what we have. Total count. Detail each stem, num iteration. So each stem is our okay. It's this loop. So let's say, okay, so we will put every other stem except the main, every other little stem from here, and you can see that we have 5. Every other little stem except the main one, which already was processed. So we'll get back to it to this one in a minute. Let's just accept. Okay, so we creating 5 points for 5 stems. And as you can see, points are created in without any order. So we want to sort them. So we're sorting them to proximity to point to 0. So the beginning of coordinates. We know that our stem will be kind of, going kind of outwards from the 0 point, because I couldn't find a way to make sure that the first point will be, closest to the ground, let's put it this way, and the last one will be furthest from the ground. And our ground is 0, 0, 0. So that was like this seemed like the best way to make sure that they will be like going in a flow for further beauty. So, and then we select the last one of them. Why offset? What did I do here? Okay, so we selecting a range between, so each stem num iteration. So this is our each stem, each of these remaining 5 stems, and num iterations, you can see there are 5 iterations for 5 stems. So we take all our iterations, which is 5. So we select 1 out of 5, and we offset it by each stem iteration. So what do we do here? Let's say that we have only 1 in common. Let's do single. Oh God, no, not this one. Yes, let's do single pass. So let's say we have only the first one. And now in this case we have iteration number 0. And if we take the second one of the smallest stems, iteration will be 1. And here, as you can see, we have selected. So for each iteration, we select one next point because of this offset, because we offset each time. So each time we select 1 point out of 5, offsetting by iteration. So on the first iteration, we select the first one. So, okay, on 0 iteration, we select the 0 point. On the first one, and so on. So for each of these incoming small stems, according to their number, so 0, 1, 2, 3, 4, for each one of them will be assigned one of the points on this line, as you can see again in here. And if we remove this, just by default, the last one is selected. So that's what we do. And again, while we do this in cycle, in cycle here, we split every time we split this endpoint. So because we named this group endpoint, and on each iteration here, the endpoint is different. And so we split it. Again, you could blast it here, just the same. So group end, that's it. So split or blast. I use them like, it doesn't matter. So again, let's see what happens here when we change this, when we change iteration, single pass. So on each iteration, you have just one point. Everything else is blasted, not selected. So let's look into this cycle. So we have our points from our remaining little stems. 5 of them. So we need to process them in a loop. What we do first, we get first of them. Let's reset. Okay, we get first of them. Just the first of remaining. We find its end, again, the attachment point, and it will be 0, of course, because now each time we have 0 and 1 points. Now we merge it with our point that stayed alive in this iteration. And again, they can be pretty far away from each other, as you can see, but it doesn't matter because we have 5 little stems and we have 5 points, and we'll connect them anyway. So we attach. Let's undo. Okay. It's not selected. Let's reset. Okay, so now we have our little point and our stem. Let's fuse them. Just the same, only end, and in this case we're fusing for the greatest point number. Let's see why. Because whatever comes into the merge. So if we put this first. So like you see how they are attached in here, they're crossed. So first we have a group range. So first we have this coming in, and then we have this coming in. So whatever comes second is getting assigned a higher point number. So we know that anyways the point on a stem will be greater. So when we're fusing, we select greater point number. So it will not this point will be moved, that it's smaller stem point will be moved. So this is how it looked before, and now this point was moved right here because that's what we needed it, because that's where our scattered points are, because this is where our branch is. So because we need to connect the small stem to the main branch, not because we cannot move the main branch because it's set. So that's why when we fuse in here, and that's why you cannot change the order in this merge, because if you change the order in this merge, this will be broken, as you can see, because the point will be moved, not the stem extended to it. So now we fused it. Now we polypath it, which is not necessary in this particular case, but if you would have more than one point, you would have to do that. You'll have to polypath. And I think that I did it for roses, and I needed to polypath because there were more than one point. Now we sort it again by vertex order to make everything nice, and we select our ends and we do our smooth. And again, you can see that we only have 1 point, but if here, when we created this tiny little stems, if we would have not 2 points but more than 2, I guess it was screwed somewhere else. In this case, you know what? I'm curious. What happened? Why they're probably because of cached path. No. Okay. Cached path here. Yes. Okay. So yeah, so if we, again, nothing changed really, except that now our branch is more flexible. So now we're fusing it like this. Now we polypath, and now we sort it, and now we select ends only to help smoothing, and now we smooth it. And so now it looks like this. You can smooth it even like less quality. So if you would have, like for instance, more situation where you would not need to try to have as little polygons as possible, you could do that too. But now we don't need this, so let's get back to just 2 points and reset the passes, and this one too. And it still didn't reset because why? Because who knows why it's not acting. Okay, now it's reset. So ends smooth, not necessary in all this case. All this not necessary in this case, but always good to have them and not need them. Then other way around. And so when we're done with all of them, each one of them is getting extended and kind of pulled towards the main stem. And that's what we have in the end. And then we clean everything. We remove all the attributes and all the groups except branch and except end. And now we have our polypathed main branch with this central flower stem attached. And we clean it as well, again removing all unnecessary groups and unnecessary attributes. And again, we still add this in separate group branches to be able to tell it from the smaller ones. And now we finally merge everything, and now we have our little stems nicely connected. And we promote attribute branch to, so when, like right now we do this in cycle, so right now we only have like we only had one branch. So we kind of didn't need to create cycle here. This is like big cycle. But again, if we want to have unique branches all over the tree, this will be the way to do that. So that's why here we create a group. Okay, so and we promote in our attribute branch, which is, well, in our case it's one, but we would have many unique branches. Now each one of them would receive separate attribute. And that's it for the branch. Now we need to actually make it add thickness to it. So let's do sweep node. And again, for saving polygons sake, I did them. So we did this round tube, but only 3 columns. So like, of course we could make it, smoother and nicer, but I only wanted 3. So we will save on polygons. And at size like that, it didn't matter. So super tiny radius, nothing fancy anymore. And also we do compute UVs. And as you can see, I did from the beginning, I did small UV scale. And let's look at the UVs. To look at the UVs, click with mouse in viewport and press 5 on a numeric keyboard. And that's how you see your UVs. So what I wanted to do is compute UVs, obviously, make a small scale, so they will occupy a little space, only a little space, because our texture only has a little strip for the branches. So occupies little space, and uncheck the things that I didn't need. So snap V to nearest tile boundary, I uncheck this because we have our branches different lengths. And again, here it's kind of very homogeneous color, so it doesn't matter. But if it was a texture, they will be kind of stretched all over the place, and I wanted to avoid it. So I'm not snapping it. If it's short branch, it's short. If it's not, if it's long, then it's long. But it's going to fit into 0 to 1 space anyways. And in here, I add UV transform node to move them to the right. And so I know that they only occupy like 1/10 of the space, and if you translate them 0.9, they will be exactly in the very end of my texture texture space. So we're done with our texturing. again, to get back to the model, click in a viewport, press 1 on a numeric keyboard. And this is done. And now we soften our normals to make like illusion that they're not triangular. And you can see that soft angle is 180 degrees. So it kind of has this illusion that it's smooth. And over here, when we copied our flowers onto initial points, I made this null node out flowers, and that's how you do this. That's why it's very convenient to use them. So because now you can do right click, merge, and do object merge. And in object merge, you have two ways to how to reference this. You can either do this, press on this button, and find it, and all the capital letters would be on top. That's why you do that. So it's easy to find. So we're looking for out flowers, right? So this is reference of this node. Yeah, it would not hurt to press OK when you find what you want. So out flowers, yeah, or double click. Or the other way to do that, is object merge. When this is selected and you like it's active, you grab this one, just grab it, don't click on it, just grab it and just pull it over here, and you can see this little plus icon. Just bring it over here, drag and drop, and that's how you do this too. So it's the other way to do that, faster. And so this is how we do a reference, and very helps with organizing the node, the graph. And so here we have our little stems, here we have our flowers, so it's the same node, and we merge them together. As you can see, like this is the part which I didn't really like, and that's exactly where having more points on our little stems would be nice, because then we would not lose this curvature. Okay, let's get here first. So out flower cluster, and now we can assign our material, and of course it always gives error. I don't know why. I mean, Houdini always does this. And this is it. And if we would have more points in our little stems, let's say 5, you can see that it will be nicer. But yeah, well, it is what it is. So let's do 2, and this, now we have it. So we have our little cluster. Again, maybe all of this is kind of waste of time. In this case, maybe it will be just much easier to create manually several different branches and then to spread them around, and probably that's how it should be done. But I was kind of curious about making this procedural, and again, this is way more useful when it comes to creating procedural roses, HDA's procedural roses for Unreal, where you can create unique things with just with a setup like this. So it's maybe not extremely useful, but again, as to me, it's looking pretty good. And by the way, also so I recommended this video about quaternions and rotations and stuff. There is also a really good channel by Nine Between, and this is the video again about orientation attributes, where he gives really nice detailed explanation of how it works, scheduling a line node in particular. So I highly recommend this video too. Very, very useful. So well, that's it for today. And you can see that actually we covered like most of it. I would say that most of it today, and it was pretty difficult parts. So kudos to everybody who stick with me, and well, that's it. We'll see you next time. Good luck.